All right, we're going to go ahead and talk here about video 2.1.5. That just means Unit 2, Standard 1, and it's our 5th video. We're still working with our graphing and identifying key characteristics of linear and piecewise functions, and we're going to be talking about different forms of linear functions today. So this is our topic, but don't forget to write down the standard and the video number. Go ahead and pause me, and when you've got that all written down, press play again. All right, so we're going to go through the 3 different forms of lines, the different ways that they're written, and the information that you can find from each of them. So they all provide a little bit of different information. The first one is our slope-intercept form, and it is most often referred to by students as y equals mx plus b. But the name of the form is not y equals mx plus b. Okay? The name is called the slope-intercept form. The reason we call it that is because we can easily look at it and identify both the slope, our rate of change, our delta y over delta x, or our y-intercept, which is written as an ordered pair as 0, comma b. Okay, so if I give you an equation, and I'm going to write it in with function notation, f of x equals negative 2/3 x plus 5, we can again easily identify our delta y over delta x as negative 2 over 3, and our y-intercept as the ordered pair 0, comma 5. Because we can easily identify that, it allows us to graph very quickly from this form. So we would start at 0, comma 5 as a y-intercept, and we would apply the slope to our point moving away from it in both directions. Because the vertical change is negative 2 and the horizontal change is positive 3, this could be one of our next points. I would do it again. You're saying, well, there could be points on the left side of the y-intercept as well. Of course. That would mean we're going to want a vertical change that's positive and a horizontal change that's negative. It still produces this line, and we get this as our line in slope-intercept using slope-intercept form. So remember what you can find from slope-intercept form. The next form of a line is standard form, and our standard form is written ax plus by equals c, where a, b, and c are integers. Okay, so we want to keep a, b, and c as integers. So here's what this would look like. 3x minus 4y equals 12. What we get from here is an easy way to find x and y intercepts. It makes it very simple to find x and y intercepts using standard form. So I'm going to make a quick chart. Our x and y's, okay, and I'm going to put a 0 in for x and I'm going to put a 0 in for y. This is going to give me my y-intercept, and this one's going to give me my x-intercept. Okay, well, how do I do that? I just use substitution. So let me grab another pen and we'll try it. That means 3 times 0 minus 4y equals 12, or negative 4y equals 12, or y equals negative 3. So one of my ordered pairs is 0, negative 3. That's my y-intercept. I repeat the process, but I'm going to put 0 in for the y value. That means 3x minus 4 times 0 equals 12, or 3x equals 12, and x equals 4. There's my my x-intercept. So when we have our standard form, it makes it really easy to graph a line. I only need these 2 points. It tells you where it crosses the x and y axis. Our third form is called point-slope, and the point-slope form has exactly that in it, a point and the slope. This form, otherwise known as transformational form, will look like this. Y minus y1 equals m times x minus x1. You will find an ordered pair hidden in here along with our slope, the m. This would be an example. Y minus 2 equals negative 4 times x plus 1. Okay. The first thing we want to do is not simplify this. Let's use it exactly the way we have it. We're going to extract our x1, y1 to find an ordered pair. When I find the ordered pair, we'll graph it. So if this is saying here that I want negative x or minus x, then what is my x1 value? Well, my x1 value, my x1 value is a negative 1. Well, what is my y value? Well, in this case, the negative sign is built in, so my y value is a positive 2. So it sort of looks like that I took the opposites of what I see, because here it looks like a negative 2, but the negative sign is built in, so it's a positive 2. And here the negative sign had turned to a positive, so I need a negative 1. This creates the ordered pair. So I have negative 1, positive 2. There's my first ordered pair. Now how am I going to get a line out of that? Well, I'm going to use my slope next. So I'm going to take the slope of negative 4. That means my delta y over delta x is negative 4 over 1. And I'm going to move down 4 in the horizontal direction here, 1, 2, 3, 4, and I'm going to move to the right 1. I'm going to do it the opposite way, and here I'm going to go up 4, 1, 2, 3, 4, but to the left 1, creating this line. So I started by identifying the ordered pair, the point. Then I used the slope and I was able to graph the line. So we have three forms of lines. We have our slope-intercept, our standard, and our point-slope forms of the line. And we want to be able to know how to graph from all of these very efficiently. So go ahead and review anything in here, and we'll talk the next time we see each other.